Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So for today, inshallah, we'll be discussing on the integrals or antiderivatives. So let me just get the slides. Okay, so this would be okay. Integration. So 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 we're gonna start with basically introducing this concept of integration as the antiderivatives. Okay, or in other words, it would be the opposite, the reverse of derivative, where instead of doing the differentiation, we are trying to trace the original function, and also the concept of indefinite integrals. Okay, so a function with the big capital F is said to be the antiderivative of a function of small f if f prime of x, if we were to differentiate the big F, we're going to get the small f. Okay, so what is big F? The relationship of the big F to the small f. Big F is called the antiderivative, or the integral of small f. Okay, for example, if we have a function, big F equals x to the power of 4 over 4. Now, this function would be the antiderivative of the function with small f x to the power of 3. Why? Because if we were to differentiate this x to the power of 4 divided by 4, we are going to get x to the power of 3, isn't it? I mean, x, if we have x, if this is our function, and if this is our big F, so if we were to differentiate this, we're going to have, so we're going to bring 4 to the front, and then we're going to get x, and then we have 4 minus 1, isn't it, divided by 4. So this becomes, so 4 going to cancels out, so we're going to, we will be, we have x to the power of 3. So as we can see, the relationship between these two would be, this would be the antiderivative. X to the power of 3 is the derivative. This is the derivative. While x to the power of 4 divided by 4, this would be the antiderivative, the opposite of derivative. Okay. So, however, the opposite, okay, is not true, because x to the power of 4 divided by 4 is not the only, okay, so put focus on the word only, antiderivative of x to the power of 3. Why? Because, for example, if we have x to the power of 4 over 4 minus 3, so if we were to differentiate this, we will also get x to the power of 3, as well as this, x to the power of 4 over 4 plus e to the power of pi. Because this is a constant, so when we differentiate this with respect to x, we're going to get 0. So we are all going to get x to the power of 3 to be the derivative. So x to the power of 4 over 4 is not the only antiderivative. Okay, it's not the only antiderivative. So we can somehow generalize, okay, generalize this result, because basically it can be any constant. It can be minus 3 plus 1, plus 1 billion, or plus e to the power of pi and stuff. So we can basically use this big capital C to represent whatever constant, whatever numbers that we have, which doesn't contain x. So this function in a general form, big F, x to the power of 4 divided by 4 plus C, would be the antiderivative of x to the power of 3, because the derivative of this big F would equal to x to the power of 3 for any real number C. Okay. So let us try to generalize this. So a function big F would be the antiderivative of a function small f if we differentiate big F, we will get small f. Okay. So the x to the power of 4 over 4 plus C is the antiderivative of x to the power of 3. Okay, so this is just a repetition. So anti-differentiation of any given function does not give a unique solution. It doesn't give a unique function, but actually it gives us the entire family of function, which we use the capital letter C, because this C can represent any real number. Okay, so this brings us to theorem 1, the antiderivatives. So basically, if the derivatives of two functions are equal on an open interval a and b, let's say we have two functions that are equal, okay, the derivatives are equal, and these derivatives are obtained within an open interval a and b, then the functions, these two functions would differ by at most a constant. So that would be the only difference. Okay, so a more detailed explanation would be if big F and big G are differentiable functions on the interval a and b, and let's say the derivative are the same. The derivative of F and G, F prime and G prime are the same for all x in a and b, then the only difference between the big F and big G will be by a constant k. Okay, by a constant k. So let's have a look at this example. Okay, so let's say we have a function x square over 2 equals, I mean like the derivative. So this is the function that is given to us. Okay, so this is our big F. Okay, big F. Let's say, so if we were to differentiate this, we will get x. Okay, we will get x. Now, let's say we have been asked, so let's say find all antiderivatives of fx equal x, and then we need to graph the antiderivative, okay, of fx that contains the point. Okay, remember, we need to basically move the opposite way. So this is the derivative. So we want to find the antiderivative, okay, and then we are given these 3 points. So we need to find the antiderivative that basically pass through these 3 points, 0, 0, 0, 1, and 0, 2. And then we are asked to evaluate the differences between these three antiderivatives. Okay, so for part A, okay, for part A, if you want to find the antiderivative, okay, antiderivative of this function, so it will be in what form? So it would be x to the power of, I mean, this is originally to the power of 1, right? This is to the power of 1, to the power of 1. So basically, this would be to the power of 2. And then, because when we differentiate, these two going to become to the front, right? So we have divided by 2, and then plus k, small k, where small k can be any real number. So this is for part A. Okay, all the antiderivative can basically k can be any real number, can be 0, can be 1, can be 2, can be 3. Okay, any real number. Now for part B, okay, the example, in the example, we need to basically graph the antiderivative of fx that basically pass through this point. So basically there would be 3, right? 3. So remember last time, so we have already basically tried to we get 2 plus k. Now we want to make sure the antiderivative, okay, that contains this point, it passed through all these 3 points. Okay, so the solution would be, so the one that passed through 0 and 0, I mean, we simply substitute these two with 0. So this would be 0 and 0. Okay, so the function that passed through this the origin, okay, would be f of x equals x squared plus divided by 2 plus 0, because 0 would be the y-intercept. And what about this? For this one, it will be f of x equals x squared over 2 plus 1. And for this, we have x squared divided by 2 plus 2. Okay, so these are all the y-intercept. Okay, the y-intercept. So if we were to basically graph this, so this would be where the graph that pass through 0 and 0. Okay, and this, the red one would be the one that pass through 1, because the y-intercept here would be 1. This is 0. And then the black graph would be 2 here. Okay, and take note, I mean, this is x squared. So if you find if you want to check for the concavity, the second derivative would be positive, right? So that's why it would be concave upward. Okay, concave upward. And finally, how this three antiderivatives are related? So basically the three antiderivative are vertical translation, okay, or they're simply shift, okay, of each other. Okay, it depends on the value of k, the value of k. So the value that k is the only thing that make this antiderivative to be different. Okay, like what have been said in theorem 1. Okay, so this brings us to this concept of indefinite integrals, the formulas and properties to basically make our analysis, our calculation simple, so that we can save a lot of time. So we're going to make use of this symbol. Okay, this symbol. This is what we call as the indefinite integral. Okay, indefinite integral. So it is used to represent the family of all antiderivative of f of x. And we're going to write this. So the integral, the indefinite integral of a function small f, sorry, fx equals to big F, okay, plus c, provided that the derivative of big F equals to small f. Okay, so this indefinite integral basically represent all the values of c that c can take. Okay, so it basically represent the whole family, the whole family of the antiderivative from 0 to whatever. Okay, I mean c can take any value. So that symbol is called the integral sign, while the function small f is called the integrand. Okay, the integrand, while the symbol dx indicates that the anti-differentiation is performed with respect to the variable x. Okay, and the arbitrary constant c is called the constant of integration. Okay, the constant of integration. Okay, so this is an example how we can use the indefinite integration notation. Okay, so the indefinite integral of x square with respect to x equals x to the power of 3 over 3 plus c. Okay, and similarly, this is with respect to t equals t to the power of 3 divided by over 3 plus c. Because when we differentiate this, okay, when we differentiate this, we should get the original integrand t square. Okay, I mean, we differentiate this, we get t square. If we differentiate x to the power of 3 over 3 plus c, we get x square. Okay. Okay. So the indefinite integration and differentiation are basically reverse operations, except for the addition of the constant of integration, because this basically represent the family. Because when we reverse the process of differentiation, okay, the process of differentiation, we basically gonna get the antiderivative, the whole family of the antiderivative. Okay, because that constant k, there is no x here, there is no variable. So when we differentiate this, this would basically become 0. So that's why when we were to reverse, I mean, we don't know, we don't have this information. So that's why we have to put the constant of the integrate, the constant of the integration c, the plus c one. Okay, the plus c. Okay, this plus c. Okay. Now, these are the formulas, just to, because formulas help us to save time when we do the calculation. So for let C to be the constant of the integration, any real number. So if we have a variable with a power n, so the antiderivative or the indefinite integral of this would be x to the power of n plus 1. We have to reverse the process of the differentiation. So now for the power, we have to add 1, and at the same time we have to basically multiply, okay, the function with 1 over n plus 1. Okay, okay, we multiply with 1 over n plus 1, or we divide the function with plus 1, okay, provided that n doesn't equal to negative 1. Okay, and for exponential function e to the power of x, basically the antiderivative of this would be the exponent itself, e to the power of x plus c, don't forget, okay, c. And then special case for x to the power of negative 1. Okay, because here we have already said this rule can only be applied when n doesn't equal to negative 1. But what if we have n to the power of negative 1? So this is basically 1 over x. I mean, negative 1 plus 1 would be 0. So we cannot have basically, you know, a negative 1 plus 1 is 0. We cannot divide the function with 0. So that's why if we have a function which is to the power of negative 1, the antiderivative of this would be the natural log of the absolute value of x. Okay, I mean, if you are not sure, you just work this, you reverse the process. When you differentiate this with respect to x, you're going to get x to the power of negative 1. Okay, and then for a constant, we can basically, because there is no x here, look at this k. If k is a constant, which is not affected by the value of x, we can actually take it outside the integral sign. It will not be affected. Okay, it won't be affected. And this is not the constant. So for basically summation, okay, addition or subtraction, okay, of functions fx and gx, we can basically deal with them separately. Okay, we can basically deal with them separately, one by one. Okay, so the remaining part of the slides are basically examples. So for instance, if we were to integrate this is simply a constant. Okay, so if we were to integrate this, we're gonna get 7x plus c. Okay, if you're not sure, I mean, to verify your answer, you try to differentiate this, you should be able to get 7. Okay, and this is a combination, so this is a constant, so we can bring this 4 to the front, and this is an exponent to the power of t, and we are integrating this with respect to t, so this becomes 4e to the power of t plus c. Okay, plus c. So this one again, we have a constant, so we can bring 3 to the front, and this is x to the power of 6. So 6 plus 1 is 7, so divided by 7, 3x to the power of 7 plus, over 7 plus c. Okay, and this we can deal with them separately. Okay, deal with them separately. So this is also, there's a plus, this is a combination, a summation of two functions, addition. So we can deal with them separately. So we'll deal with the first term. This is the exponent with the constant. So 3, we can bring it to the front. E to the power of x dx plus, and this is 4 over x. So this 4 is a constant, we can bring it to the front. And this is basically 1 over x dx. So what would be the answer here? So this would be 3e to the power of x, isn't it? Okay, plus, now 4 is a constant. What about 1 over x? This becomes natural log of x. Plus, don't forget our c. Okay. Another example. Okay, so this is 5. So we can basically simplify this. So this is, we can bring 5 to the front. So this then becomes what? So this is, so x to the power of negative 4 plus 1. And then divided by negative 4 plus 1. Okay, and don't forget our c. So this becomes x to the power of negative 3 divided by negative 3 plus c. Okay, and of course you can rewrite them in a more elegant way. So this becomes negative 5 over 3x to the power of 3 plus c. Okay, I'm going to leave the remaining examples to you, because so to make sure you're familiar with the 5 formulas that we have shown earlier, and try your best to I think do the integration, as quickly as possible. You just need to be careful. Okay, I mean, okay, so let's try to do this together before we end the session. So this is basically 2x. So let us just, these are the subtraction, right? So we can basically separate them. 3 dx minus real 6x to the power of half dx, right? Because this is subtraction. And this is constant, so we can bring this to the front, right? So this is x, okay, to the power of negative 1 over 3. Okay, so this is, let me just finish rewriting this. Dx minus, again, 6, we can bring it to the front, x to the power of 1 over 2 dx. So now we can do the operation. So this is x to the power of negative 1 over 3 plus 1. So 1 is 3 over 3, isn't it? Okay, so be careful. So this would be, just rewrite the whole thing here. Okay, minus 6, and this is x. 1 over 2 plus 2 over 2, right? 1. So this is 1. We're going to add with 1. So this is basically 1 over 2 plus 2 over 2 plus c. So don't forget our our constant of the integration, and then just carefully open the bracket and try to simplify the calculation here. So this is 2. So negative 1 over 3 plus 3 over 3. So this would be to the power x to the power of 2 over 3 divided by 2 over 3 minus 6. So this is x. So this become 3 over 2 divided by 3 over 2 plus c. Okay. And so we can basically simplify this further. So this is 2 divided by 2 over 3. So we can cancel this out. And this is 6 divided by 3. So this becomes 2. And we have 3 here. So these 3 can bring up. So it becomes 3 to the power of x to the power of 2 over 3 minus. So this is 2, this is 2. So bring this 2 up. 2 multiplied by 2 is 4x. 3 divided by to the power of 3 over 2 plus c. And this would be the answer. Okay. So example 4, I'm going to leave this to you. And that's so another example, cost function as well as advertising. Okay. So in kind of a more, it's a kind of a problem. For example, you are given this would be the derivative, right? This is s prime of t. S prime of t. So basically, so okay, let's go through this example together. So this is a radio station, okay, having this advertising campaign 16 days ago in order to increase the number of daily listeners. So the station currently has 27 daily listeners, and management expect the number of daily listeners st to grow at the rate s prime of t 60 t to the power of 1 over 2. So this is basically the rate of change of listeners per day. Every day, the management expect there would be 60 multiplied by t 1 over 2 more listeners per day, where t is the number of days since the campaign began. So how much longer should the campaign last if the station want the number of listeners to grow to 41,000? 41,000. So basically, you need to find the solution, to solve the equation st equals 41,000. Okay, because s is this is the function of the advertisement campaign. Okay, so we want the total number of listeners to be 41,000, and these are the information that we know. S prime of t, which is the derivative, okay, the rate of additional listeners for every day will increase by 60 multiplied with the t 1 over 2, and the total number of listeners after 16 days. Okay, after 16 days, currently 27,000. Okay, 27,000. So based on these two information, we basically need to, so we have this is the derivative. We want to get the original function, st. So what we need to do, so given s prime of t equals 60 p 1 over 2, we need to basically integrate s prime of t with respect to t. So where this basically equals to 60 t 1 over 2 dt. So how do we integrate this? So this is a constant, right? I mean, it should be very easy. So this becomes 60 integrate t 1 over 2 dt. So this is to the power of half. So this is going to basically becomes t 1 over 2 plus 2 over 2 divided by 1 over 2 plus 2 over 2. Don't forget our c. So this becomes 60 t to the power of 3 over 2 divided by 3 over 2 plus c. Okay. So simplify this, 60, so 60 divided by 3 is 20. 20 multiplied by 2 is 40 t to the power of 3 over 2 plus c. Okay. And the information given to us, so this is basically our s of t. Now we need to solve for this c, this constant, by using this additional information here. So we know that s, when t equals to 16, equals to 27,000. So what we need to do is we simply replace this with 60 to the power of 3 over 2 plus c equals 27,000. Now surely we can solve for c. So what is our c here? So 40 multiplied with 16 to the power of 3 over 2. Okay, this would basically be our c here. So use your calculator, okay, so that you should be able to see that our c here would equals to 24,440. Okay. Okay. So okay, this is simply what we have done before. So this is the general integrated function of this s prime of t. Okay, so this is the original function, but we have c here, the capital C here. And we use the additional information that after 16 days, S of t would equal to 27,000 listeners. So based on this information, we can solve for C. We simply substitute this t with 16, and then we can solve for C, where our C is now 24,440. So from all this family of antiderivative, there is only one function, okay, that basically solve our problem, where our original function s, which is a function of t, equals to 40 t to the power of 3 over 2 plus 24,440. And now we can basically solve for the original question, original objective of the question, where our target is we want to know how many t does it need for us to reach 1,000, right? 41,000. We want this. So what is t then? So how do we do that? We simply substitute this. So st equals to 41,000. So 40t 32 plus 24,440 equals to 41,000. And then try to solve for t. Okay. So use your calculator. Your t then would then equals to about 55 or 56 days. Okay, 56 days. So for 56 days, so the campaign, okay, the campaign has already lasted for 16 days, isn't it? So 16 days already. So how many days left? Another 40 days needed. And that's basically the answer to the problem. So I'm gonna end this one here. Okay, and let's try to go back to this one. And so by now, I hope you already know how to find the antiderivative. And also when you are given with this additional information, you should be able to solve for the value of the constant of the integration, that C. Okay, so that's all for now. Inshallah, we'll meet again in another video, inshallah. Assalamualaikum warahmatullahi wabarakatuh.